Yeah. Hello, everyone. I am Grisha Skobelev, Java backend developer, and my co-host Nikolai Golov. Коля, hi.
Hello. Hi, everyone. I'm head of data engineering of ManyChat, and also I'm a researcher of databases and data modeling techniques. So I'm also happy to see all of you, and I am extremely happy to see Mартином Клеппманном, who agreed to participate in our small meeting.
Hello.
Yeah.
Nice to be here.
Yeah, we have a surprise. We recently finished reading and discussing book Designing Data-Intensive Application by Mартином Клеппманном. This is a great book what gives us a lot of positive emotions, and I am so glad what Mартином Клеппманн agreed to the interview. We will provide some questions about the book, also talk about the future database systems and Martin's new research. And NZF, like old tradition, we will take photo with the book. Hi, Martin. Tell us about yourself, please.
Sure. Hello, everyone. So at the moment, I'm a research fellow at the University of Cambridge. I'm mostly working on collaboration software these days. So type of software like Google Docs or Figma or so, where several people can edit a document at the same time. But before that, I spent a while writing this book, which you know, which came out in 2017. Before then, I worked in startups for a while, and I worked at LinkedIn for a couple of years doing data infrastructure there.
Wow, fantastic. Before we start, we have three small talk questions. What will be interesting for our community? First one, what your favorite programming language and why?
My favorite programming language. I hate all programming languages. I don't have a favorite one. No, actually, if I had to pick something as my favorite, I would prefer the language of mathematics as it's not technically a programming language, but you can kind of use it to express programs or specifications or things like that. And I still find just standard mathematical notation, just set theory and first order logic and basic things like that, actually one of the best ways of concisely expressing ideas in a way that's short and precise. And I find no programming language that I've used really gets close to that. I mean, there are languages like TLA+, which are essentially mathematical notation. So that kind of gets close, but I would say that would be my favorite language.
It's good options. The second one questions, your mistake or fuck up, which are you ready to include in your resume?
So something that I got really wrong. One story might be of a product that I built while I was at LinkedIn. So this was almost 10 years ago or so. And we were trying to change the way that email works on mobile devices and add social media information to that. And the way we did that was we wrote our own IMAP server, which essentially proxied all of the emails between your mobile device and your actual email provider's server and modified the emails as they were flowing through that server, which was kind of technically sort of mad, crazy genius idea. And it worked surprisingly well. But I think the mistake that we made there was underestimating how much people would hate it, because people thought it looked like a man-in-the-middle attack, which it wasn't really, because it was opt-in. It's only if you configured your device to use it, then you would go via this server. But I think that really annoyed people a lot, and we got a lot of very bad press for that. So I think that's probably a bit of a mistake in retrospect.
Thank you what you shared it with us. And the last one, small talk questions, it's what inspired you to work in IT?
Well, I mean, in some sense, I don't work in IT anymore. I work in education now, since I'm at a university. But I mean, I have been interested in computers for a long time, since a teenager. I originally started doing electronics, actually, and only got into programming computers a bit later. But I found what has kept me in the field has been the feeling that it's a way of potentially helping a lot of people, indirectly through software that they find useful, through valuable services. It is a way how we as computing people can have a bit of an impact on the world, helping people be better at their jobs, for example. And I think that is a valuable thing to be doing.
Thank you. It's interesting thing. Nikolai, we don't hear.
Yes,
Yep.
as an organic like continuation of your previous topic. So you have mentioned that you are working in education. So for whom, when you started writing this book, for whom it was written? For what audience? For what people? Maybe somebody asked you to write it.
Yes, I started writing this book because I wanted some book like this to exist, and I had looked around and I couldn't find anything like it. There were a couple of books on like scaling MySQL databases or stuff like that. So they had some of similar ideas, but they were often very specific to one particular tool. And often they didn't really have a good discussion of the trade-offs, like what are the pros and cons of doing different things. And I really wanted to understand that better. And I had struggled with that previously when I was in startups. We had a fairly large Postgres database, and we had all sorts of problems just managing that and using it productively. And so then while I was at LinkedIn, I had the good fortune of being able to work with a lot of people who done very smart things on large-scale data systems. And so there I was able to pick up a lot of ideas from people on how things are built at scale and why they are built that way and what the trade-offs are. And really, I just wanted to make that sort of information accessible to a wider range of people, kind of like myself being in the same position 5 or 10 years previously. So I set out to write the book that I myself would have wanted going into the industry as a way of just really understanding the landscape of technologies for storing and processing data. And yes, that is then what I presented to the publisher as my plan, essentially. Like, I wanted to have this book that was designed mostly for software engineers, but also to some degree for data engineers, for technical managers of teams, for architects and so on, everyone who needs to make decisions about what technologies to use and why. And I feel for those kind of people, it's very important to understand what questions they need to ask, because like I can't tell you what database to use because it depends vastly on what you want to do. And really what I wanted to do with this book is teach people what questions to ask so that the readers could then answer for themselves what tool is the right tool for the job that they are trying to accomplish right now.
Mm-hmm. Yes. And are you getting some feedback from readers about this book? So maybe some readers are not agree with you. Maybe some of them are offering something. Just like as a small illustration, for example, in our chat, for example, we had a huge discussion about those inconsistent notion of consistency. ACID, CAP, consistent hashing, and a lot of people simply cannot believe that it is possible that one term can exist in different meanings in different areas. So,
yes, it's kind of very poorly coordinated if you think about it in some ways, but in other ways it should be unsurprising, because remember that all of these systems that exist, all software systems and all computer systems, were just created by other human beings. And to be honest, human beings are kind of chaotic and badly organized and just kind of muddling their way through and sort of doing what they can within their little scope of influence. And actually coordinating things is really hard. And so it does just happen that one community starts using a word in a certain way, a different community starts using the same word in a different way. Those communities grow together gradually. That's what happened with distributed systems and databases. Like traditionally, distributed systems and databases were two totally separate communities that didn't talk to each other. And then eventually we ended up with distributed databases, and now suddenly these communities have got merged together. And so the words which mean one thing in one community mean a different thing in a different community. And so I think for that reason, like we have to accept to some degree that there's some confusion about terminology, and we just have to clarify in which meaning we mean the word. But I don't think it's worth getting too upset about it. Mm-hmm. But your actual question was on readers giving me feedback. That has been very interesting. So I occasionally go along to, like yourselves, reading groups that have read the book. I get a fair amount of email from readers as well. And there's O'Reilly has an errata system through which I get submissions sometimes. And often they're kind of very specific things. You know, there's like this particular paragraph on that page in that chapter I'm confused about. And that's valuable for me because it's, it means that, okay, I need to change the explanation of the concepts there to make it clearer. Sometimes it's just questions of like, I didn't really understand something. And the questions then lead me to rethinking what sort of structure should be in place to try and convey the ideas better. So right now I'm just getting started on writing a second edition of this book, which is, don't get your hopes up, it's still a long way away. I've not even finished editing the first chapter yet. But it is meaning I'm kind of back in that sort of absorbing information mode where I'm talking to a bunch of people and trying to get their sense for what are the important questions that people should be asking, what are the new developments, what are the new trade-offs, and so on. And so I get a lot of ideas just from conversations with people. That's why you can see it, I think, in the preface of the book. Also, there's a long list of thank yous to people. I'm sure I've left out people there accidentally as well. There's a lot of people who have had input into this book as a way of helping me shape my thinking around these topics.
Mm-hmm. And by the way, I suppose it's mostly feedback from like normal people like us, but maybe you do have some connections with people or companies or startups who are creating new databases. Maybe you are participating. Maybe you can tell us some story about some databases which shall emerge soon. Or
I hear a bunch of stories about new technologies. I get a bunch of stuff just from Twitter, like other people as well. Sometimes it's through personal conversations with individuals. What I find the most useful is occasionally talking to the engineers working at database companies to get their opinion on what their database is good for and what it's not good for. Because that's often something that you cannot find in their public websites, because the website is always pretending to be like, yeah, we are awesome, we do everything for everyone, and no matter what your problem is, we can solve it for you. And that's nonsense, because there's no tool in the world which can do everything for everyone. In fact, if you tried to do everything for everyone, it would be quite a bad tool, because it would mean it does everything badly rather than doing one thing well. But often it can be difficult to really get an idea of what are the things that this tool does well and what are the things it doesn't do well. And one of the best ways I've found of finding out about that is to talk to the engineers actually building it. And I find that they have a very clear idea of what their systems are good for and what they're not good for. They just don't often say so in public.
Yes, because I suppose speaking with you, they can be fair because it's not a public interview, which can be cited by reporters.
Exactly.
Next question. One of the topics which aroused a lot of questions in our community. It was distributed transactions. It was sagas, because some of us have, for example, me, we had an experience with implementing sagas. We understand how complex and dangerous it is. Do you believe that in the nearest future we will have some solution for distributed transactions?
It's a difficult one because you're really up against the fundamental limitations of, what you can do in distributed systems here. So I think to some extent, I don't think a better technology can magically fix distributed transactions, because it's just inherent in the problem. If you want atomic commits across multiple different systems, for example, that's just going to be inherently a difficult thing to do reliably. Fortunately, I think there are like other ways of working around that. So I did at some point propose an approach that I called online event processing, OLEP, which is sort of an attempt to do similar things to distributed transactions, but without actually having two-phase commit or similar protocols, but instead using streams, event streams and stream processors. And that gets you fairly far. It doesn't quite provide the sort of idea of distributed serializable transactions that you might want in an ideal system. Now, sagas are quite a difficult thing to get right as well, I feel, because I think that there aren't really any established techniques that tell you whether your implementation of sagas is correct or not. It's always very application specific, very ad hoc. You kind of have to make up the rules as you go along. I don't think there's very good guidance on how to implement sagas well. And so I think that although it's a popular pattern, I feel that's not really a great solution either, just because, if you've got an implementation, how do you know that it actually provides the properties that you want? How do you reason about concurrency that might happen where if you have two concurrently running sagas that interfere with each other in some way, and then you need to roll back one but not the other? Like, how do you deal with that? It's basically unanswered, and maybe it might be unanswerable even. But yes, I'm not sure we've really found an ideal solution among any implementations yet. So I feel like this online event processing might be part of the answer, but even that is only a partial solution.
Yes, we implemented sagas only starting from third attempt. And we even invited Chris Richardson to confirm that we understand everything right. It was a very long and very painful process. I don't recommend anybody to repeat it.
Yes, and it's, if you need to hire an external expert in an area to validate that your system is correct, then that suggests to me that we haven't got the programming model right yet. That means it's too hard to use, too hard to do correctly. And maybe somebody very bright will come up with a better programming model that's easier to use and doesn't, that's the people. You don't need a PhD in distributed systems in order to do it properly. But I think that would be a good goal for the community. But I'm not sure we're there yet.
Yes. We have a great question from our audience about the next book. Do you plan to add some exercises there which maybe can help people to understand ideas better?
That's an idea, yes. I'm not currently planning to add exercises. The reason for that is I feel it depends on the style of book. And so I know that in sort of academic textbooks, it's standard to have exercises. And that works very well for books that are used as a course text for a university course, for example. For designing data-intensive applications, the goal was actually never to be a course textbook, but the goal was to be a book for practitioners, for software engineers working in practice as a more practical guide to systems. And personally, my feeling about exercises was that I find them a bit patronizing, like a bit, trying to solve artificial problems for the sake of solving problems. I do understand that sometimes they can help deepen understanding better. I just feel that it's kind of a different style of book. So I have played with the idea of writing a separate book on distributed systems, which would be much more of a traditional university textbook style. And that then would have exercises if I do ever get around to writing that. But I feel that designing data-intensive applications is just a different style of book. What would be really cool actually is to have exercises that are not like solve this question, but more like ideas for projects of things people could implement. So more like project ideas rather than like right or wrong answers. That might be a fun thing to do, but it's difficult because then you start getting into like which specific tool are you using, and so depending on like which database you choose to use, then you have to have a whole bunch of ceremony on how to set it up and how to actually get your working environment and everything set up. And I feel that would all be distractions, and the book is long enough as it is. So I want to avoid, turning it into 3 times as long, because then, nobody will want to read it. So I'm actually trying to find ways of adding less content, adding as little content as possible. Maybe some sort of like, it would be really fun for there to be some sort of book that is much more hands-on, like let's build our own database from scratch from first principles or something like that. There might be some book out there like that. I haven't looked recently. I believe there is a similar book for like, let's build our own web browser from first principles. And I love that idea. That's a very cool way of teaching, but it's very different from my current book. I think that would be a separate book.
Yes, sounds like a description of another book which is not existing, but maybe it is a good idea to create it, or maybe for somebody from this audience.
Absolutely. If one of you wants to go and write it, that would be wonderful.
Yes, Grigori, let us switch roles. Your questions.
Yeah, we have 3 questions about book. If you have 1 hour, which chapter you're gonna read in your book?
I would say it depends very much on why you're reading the book. What problem are you trying to solve? So, are you thinking about data modeling? Are you thinking about fault tolerance and like being able to tolerate nodes disappearing and crashing? Are you worried about scalability? Are you worried about data consistency? So depending on what you're interested in, I think the answer looks very different.
Yeah, depended. And second questions about the cover of the book. Why is there war on the cover of the book?
That's something that O'Reilly is very particular about. So as you probably know, O'Reilly has these animals on many of their books. And when I was working with O'Reilly, they're very reasonable publisher. Most things, they just let me do whatever way I like doing them. Mm-hmm. But with the animals, they are strict. With the animals, there's one person at O'Reilly who makes all the decisions on which book gets which animal. And authors get no say in the matter at all. I could suggest animals if I like, but my suggestion will be ignored and they will pick an animal for me. And that decision is final. So that's the way it works. They don't really explain why they pick a particular animal. Often they say there's some sort of like lateral thinking association. So I don't know, maybe it's something about intensity. Maybe they felt a boar is an intense kind of animal, would be my guess. But this is purely speculating. I really don't know how they choose animals.
Yeah. Nikolai?
So you don't think that they discovered some similarities between you and... but I like boars, I suppose they're great animals.
Maybe I'm a wild boar in secret.
By the way, so about your book, a lot of parts of this book, they're like educational, but the topic which I discovered to be extremely interesting is like section article is about future of databases. Mm-hmm. So what do you think about future of databases? Do you have some like feelings or beliefs about what databases which emerge in the future. Do some like your thoughts about this topic changed since you finished the book?
Somewhat. So I guess there are a bunch of ideas in the final chapter on what the future might look like. I still feel like most of them haven't really happened yet. I don't really see very convincing implementations of the ideas. I guess so. Like one of the core ideas there was that rather than having this request response model where you query the database at one point in time and then you get the result which represents the state at that point in time, and then thereafter if the data changes, you don't know. The only way of finding out if the data changes is by repeating your query. And yes, you can keep repeating it, of course, but that seems ridiculous. Like, why should you have to keep polling? It would make much more sense if you could subscribe to query results changing so that whatever data is on the screen can be refreshed automatically when the underlying data changes. And, there are some systems trying to do this. Like one thing that comes to mind is Materialize, is a startup that is trying to do essentially stream-based materialized use of SQL queries. But it's still quite a niche thing, and I feel there's a vast pile of legacy software that has been built on the assumption of this request response paradigm. Like every single REST API is inherently request response. There's with plain HTTP, there's no way of pushing updates back to the client, so there's no way for the client to subscribe. Yes, you can have WebSockets, you can have like server sent events and stuff like that, but that's all extensions. In the core model that most REST APIs use, you don't have that. And I feel that's quite a missed opportunity to have a way of, but partly I guess that why it's not happened is that it's just so difficult because there's so many layers of the software stack that have to be changed if you want to move to this more streaming, more subscription-based paradigm. Like every single ORM library has to be rethought. Every single application, that just the entire data flow through the application looks different. I've kind of been coming at a similar related problem in my research. I mentioned I was working on collaboration software. So I've been interested in like how do you build a Google Docs or Figma or an interactive spreadsheet or that type of software where you've got several people editing the document in real time. And there also you have this property that if one user changes it, you want to push that change that the user has made in real time to the other users so that the other users can see with low latency what is happening. Now, weirdly enough, the technology stack for building those sort of real-time collaborative software is totally different from the typical technology stack for building web apps or REST APIs. Like the protocols and algorithms and libraries that people use are all totally different. And I don't really see fundamentally why they should be different. That seems more like a sort of historical artifact. But maybe, over the future, we can try and bring these things together so that every piece of software has this sort of live updating in the same way as Google Docs has. Because it seems to me like, why would you not want it? Why do you want outdated information on your screen if you could have live updating information? Like it's clearly better to have the live updating information for the vast majority of use cases rather than having some outdated, stale information on your screen. And so yes, I feel that's still that sort of vision for the future is still there. And I think a few people have started working on it, but I don't think it's really become a mainstream thing yet by a long way.
Oh, yes, to clearly understand the requirements which you have mentioned, when you described this idea about events, about changes, I was thinking about something like Kafka, about databases, where you can subscribe to changes and get information. You're speaking about something like it?
Yes, like Kafka and stream processing systems are part of the story, but that's only a small part. That's only, you're in a data center, you want to publish, subscribe to a stream of changes of events. And yes, you will probably need something like Kafka. But then, how do you get when an event happens in Kafka, how do you get the effect of that event all the way so that it appears on the user screen? That to me is the interesting question. Like, there are lots of layers of application code and libraries and RPC frameworks and user interface stuff and so on that event needs to go through. So, what happens on the path from receiving a consumer event on a Kafka consumer all the way through having the user's screen updated? That seems to me like the interesting question.
Yes, I think it is a good place to switch to a topic which you have mentioned, which you are currently studying, this CRDT, conflict-free replicated data types, because we, you have just touched this topic. So we was discussed it a little with Grisha. Maybe let me just try to explain the idea of your research to Grisha, and you say what parts I understand wrongly.
Great, go ahead.
So in my understanding, the idea of this CRDT, let me copy the name to the audience, because my English is not perfect, was to switch from a client-server paradigm of storing information, that you have client, which changes information on the server, switch to the idea that each client have its own copy of data, which each operation on the client are being stored primarily there. So each client stores his own data, but those data from a client, they are seamlessly integrated, they're seamlessly transferred to the other places where other person can work with them, can also see the changes. So you have in your website, which you sent us, you had a great example of Git, like multiple person, like GitHub, all the others, like different person makes a changes in the single data structure, and those changes are smoothly combined. Mm-hmm. So doesn't sound correct. Maybe you can improve something or add something.
Yes, that's a good summary. So CRDTs are actually used in two different environments that are quite different, and I can maybe briefly explain that. So firstly, they are used in server-side databases as well, so on cloud databases. So for example, Azure Cosmos DB and Redis and so on, a couple of databases have support for CRDTs. And what they do there is, if you have several replicas, so several servers that have a copy of some database, what you have to always answer is like, how does that data get updated? One option is to have one of them as your leader, and every time you want to update it, you have to send the update to the leader, and then the leader disseminates the update to the others. That's one way of doing it, but sometimes it's better to be able to write concurrently to multiple replicas. And then what happens is that those replicas have actually become inconsistent with each other, and you need to merge their states somehow, and so that they converge back to the same state. And this merging process is something that CRDTs can do. Now, you can also use CRDT on the client side, and that's the area that I've been looking at mostly, and that's what you were mentioning here. So if you want to build some collaboration software, say a Google Docs style collaboration, what happens is inside your web browser, as you are editing a document, you have your local data. You have in your web browser a copy of the document that you're editing, and every time you type a keystroke, you are modifying your local copy of the document. And what you want is that every time you type a keystroke, you don't have to wait for a round trip to the server and back again before you see the character appear on your screen, because that would be really annoying, because it might be 200 milliseconds round trip time, and that would be really painful for typing. So what we want is that your own copy of the document gets updated immediately, and then asynchronously in the background, that keystroke, whatever you just typed, also gets sent to the other people who also have that document open on their computers, so that they can see the update. And what happens here now is then, again, you have different users with slightly inconsistent copies of this document, because your colleague is also typing on the same document while you're typing, and each of you is updating your own local copy first, and then asynchronously sending the update to each other. And so again, you have the same state where you've got two copies of the data which have diverged slightly, which are slightly inconsistent with each other, and we need to merge them back together. And yes, so CRDTs are algorithms that do this kind of merge. You can think of it almost also like in a Git repository, you could have branches which then merge together. And the way that works in Git, is if you have the edits far enough apart, so one user is editing the top of a file, another user is editing the bottom of the file, then Git will merge those automatically into a file that contains all of the changes. But if you try to edit the same lines or lines close together, then Git will give you a merge conflict, and then it's up to yourself to sort it out. And what CRDTs try to do is essentially automate the merges so that you never have to have a manual merge conflict. Now, that's why they're called conflict-free. Now, in practice, you can't really get truly conflict-free. What you can do is you could always merge everything together and ensure that everyone ends up in the same state, but that final state might not actually be what you wanted. And so you might have to still fix it up afterwards. And that's just inherently part of life. If two people change the same sentence in the same document, there's no clever algorithm that can fix that. Eventually, that's just something that the humans have to fix. But what the CRDTs can do is they make the routine merging of changes much, much easier. So in the common case, where the users are not editing the same part of the document, but they're editing different things, then the CRDTs just give us an automatic way of merging those changes together in a way that's nice and easy. Mm-hmm. And now the way it works essentially is that you model your data in terms of data types. And that's where the data types DT part of CRDT comes from. And so you could have a list data type, for example, or a map, key value mapping, like a dictionary, or a couple of other types. And you can build up your application state from these data types. And so CRDTs allow you to model your application's data using these type of data structures that know how to merge themselves.
Yes, when you described it, I'm just, in my current company, in ManyChat, we are creating chatbots. We are by visually programming a flow of data processing. So like each chatbot is a flow of actions, of conditions, all the stuff, like directed as a grid graph. Mm-hmm. And when I started working for ManyChat, I was really shocked that when a person edits this doc in his browser or on his mobile application, it is not a constant client-server communication. All editing is based on the client, or only JSON is being edited, and test runs are also executed using this JSON on the front end. But just at the end, when person selects publish, only at that moment, this JSON was sent to a server, parsed there, and stored in the database. Mm-hmm. So I cannot even believe that it is possible. Yes, because I was ready to approach it any small changes change event to the server.
Yes, and I imagine if you have two colleagues editing the same flow, then one will just overwrite the other, and one of the people's changes will get lost, presumably.
Yes, JSON is it's a thing as a whole. It is written as a whole. So I think maybe so. But by the way, I suppose JSONs can be processed and merged using this technology. Yes.
Exactly. Yes. So I work on a CRDT library called AutoMerge, which will allow you to build exactly this kind of software in a real-time collaborative way. And so the way it works is it gives you a JSON data model, and you can put whatever data you like into it. And every time you update the data in any way, like for example, you use your mouse to drag and drop a box from certain XY coordinates to other XY coordinates or something like that. Or you edit a field, one property of one of the boxes, or you draw an arrow between two boxes. Each of these would be an update, and the AutoMerge library tracks those updates in a fine-grained way. And so yeah, you can see exactly like which property changed from which value to which value, or you added an item into this list object. And it can then encode that change to the data just as a byte array, and you can then send that byte array over a WebSocket connection or whatever you like to a browser, to anyone else who's also got a copy of that document open. And anyone else receiving that can take that byte array and apply it to their own copy of the data, and they will see exactly the change that you just made. And if two people make changes concurrently, then the data structure automatically guarantees that they can be merged cleanly, so everyone ends up in the same state, even if they receive the messages out of order. And so that's exactly what you described is exactly an example of the types of applications that we want to enable, to allow them to be made real-time collaborative, and to also allow incremental saving, so that every time you make a small change, you can persist that change, maybe locally in the web browser or maybe on the server, wherever you like. And so you can essentially accumulate just this log of changes. And from time to time, if that log gets too long, you can compact it and you can save the entire state. And so AutoMerge provides those kind of serialization interfaces that make it easy to get incremental updates, but also save out the state of a document and load it again.
Yeah, Nikolai. Yeah, if we return to database, we have some questions about if you need to choose database for a company, what question would you ask the business first of all in order to understand what kind of database you need?
Okay, that's a difficult one. I'd probably first try to understand what type of users are using this database and what for, what types of queries are they making, what type of data are they putting in this database, and resulting from that, what are the access patterns? That's really the fundamental thing here. So if a database is going to be used for analytics, where business analysts have big queries that query a huge collection of some huge fact table in a data warehouse, something like that, that's a very different type of using a database from it's a transactional database. It has to it has to handle a million concurrent connections from users around the world who are all making small updates and small queries to it. So whether you've got this sort of analytics type workflow or this sort of transactional type workflow makes a huge difference in terms of what you would use. So that would probably be my starting point. And then going from there, then you can start talking about things like data model. Does it make more sense to use a relational model, or a graph-based model, a key value model, document model, whatever? In terms of the scalability, you kind of want to know, like, is it sufficient to just have a single server, or is this going to have to be a partitioned, sharded system? If so, how do you decide which things to put on the same shard? How do you make sure you get reasonable locality and so on? So those are then all different questions that are second order.
Yes, I suppose, and if you have mentioned those locality, I suppose we have just question about it from Dmitry. Can you ask, please?
Yeah. Hi, Martin.
Hello.
Yes. So I have a question about it's tricky question. What is your preference? Do you prefer to collocate data with a database and execute collocate data and business logic within a database and like have some ability to execute a business logic within a database, or maybe have some database within your application? Or you prefer to have a strong separation, like I would like to have a simple database with some primitives and all business logic should be executed on application side and complete separation? What is your preference?
It's a good question. I don't think I have a preference. I think it's, as always, it's a question of trade-offs. It depends what your concerns are. I would say the trade-off in this case is if you put more logic inside the database, then that potentially allows the database to do things more efficiently. So there are some databases, for example, which make very good use of stored procedures, where stored procedures is essentially saying, let's take a bunch of business logic and deploy it to the database so that the database can run it. And that way, you're almost using the database like an operating system as a way of a place where you can deploy some code. And there's some databases like VaultDB come to mind, for example, which are able to, if you are willing to put your database in these stored procedures, then they can get you some very nice performance based on just the way that they execute transactions, and you get some very nice properties. You get serializable isolation, which would otherwise be very expensive if you have the application code on one node and the database on a different node, and they have to interactively talk over a network. That just has very different performance characteristics from the database can execute the application code on the same node as where the data is located, and thus it can execute that transaction really fast. So that's the pro of stored procedures and putting application logic in the database. The downside is that databases are not really great places for deploying code, because often you're limited in terms of what kind of libraries you can use or what kind of programming languages you can use. Often there's no good logging or no good operational visibility into the memory use or the CPU use or the just generally performance patterns. This is something that operating systems have been developed to be very good at, and databases, well, their database is pretty good storing data, but they're not very good operating systems, to be honest. They're sort of just about tolerable operating systems, maybe. And also the way of deploying new versions can be difficult. You have to do a SQL transaction in order to replace the old code with the new code. How do you get the code there? Do you have to upload a jar file? Do you give it a Docker container? Do you give it a WebAssembly module? I don't know. Has to be some way of getting the code onto the database. And that's those sort of questions of tooling I could imagine could be solved if people just invest in them better. That could become better, and then maybe it becomes more appealing to run more application code in the database. But right now, my feeling is that the tooling is still not really great, and so that is probably a big reason that puts people off putting logic in the database, just because the deployment and also the versioning, how do you know which version of your stored procedure the database is running right now? How do you update from one version to another, and so on? All of those things that are really important in practice.
Yeah, and maybe some related question. Do you see some relationship between this topic and CRDTs? Should be CRDTs gain some atomic plane entities, or we should move more business logic into this area?
Yeah, there's an interesting connection there. So where I'm trying to go with my research on CRDTs is a style of software that we call local first software, which is essentially a move away from the cloud. We're saying, cloud services are great and nice and convenient, but they're also very dangerous, because if somebody stops paying the bills for that cloud service, then the service goes away and all data that was stored in that service is gone away, and users lose all access to all the data they've ever created with this. And this is a really bad situation. So really what we would like is for more of the data to be stored on the user's own device locally, so that even if any cloud services go away, you've still got the software installed on your own device, and it's got your data there, and you're not going to lose that. And so this is a bit related idea, because now what we're saying is that we're going to have the software that manages your data, and the data that it reads and writes, they're going to be located on the same device. But this device is now not a cloud server, but it's your own laptop, it's your own smartphone, your own tablet. So in some sense, that gives us back this sort of stored procedure-like thinking, in the sense of you're only operating on data that's on the same computer. And that gives us some very nice properties. You don't worry about what if the network connection times out, for example, because you're just talking to your local hard drive. That doesn't normally time out if it's reliable. And any data synchronization that happens with other computers, well, that can happen in the background. You don't have to wait for it. And so you actually have a much simpler programming model if you're programming against data that is local in the same process, rather than remote on some other machine. And so I think that's probably a similarity there to the stored procedure model, except in the stored procedure model, you're saying, I'm going to take my application code and put it on the server, and the data and the code will both live on that server. Whereas in the local first model, we're saying, let's put it all on my own device. I'm going to put both the data and the application logic on my own device. And both have the effect of bringing the code and the data together, but they're in different places.
Okay, thank you.
Yeah, thanks. So unfortunately, I see that there are some other questions, some other people which I want to ask something, but unfortunately our time is almost over. So Grigory.
Yeah, maybe we have time for one more questions from Artem.
Thanks. Yeah, so going back to the book itself, quite general question, I think. It's been 5 years since it was written, but well, it's quite relevant, all the information. That's why I think we're here. Like, the question is, do you think, is there anything to actualize, and what would you actualize these days in the book? If it's
yes. Yeah, so I've been thinking about that quite a bit. As I mentioned earlier, I've started work on a second edition, and so I've been, since we published the first edition, I've been collecting list of ideas for things that could do with updating. Part of it is a lot of details. So, just like some databases have changed their technology a bit, or they've got better something or another. But that's mostly uninteresting. That's fine polish, but it doesn't affect the big picture. There are a few big picture changes that do change the foundations, though. One thing is the emergence of cloud services that in the first edition I didn't really get into. So I feel that nowadays it's becoming very popular for people to just use a hosted service that's run by Amazon or Google or Azure or whoever, and to use that as just the data storage you trust. And so there's much less of this model of like you install Postgres on your own machine and you manage it yourself, and much more this idea of outsourcing it. Now, not everybody does that. Obviously, some people still want on-premise software and hardware, and that is totally fine. But I think just the discussion of the trade-offs around cloud services need to be much more front and center in the book. So that's one of the updates that I'm making. Other things that have changed, that the regulatory environment has changed. So the GDPR has come out since the first edition, and I feel that many of us working on data systems still don't really know how to deal with that. How do we make systems that are easy to make compliant with privacy regulation as it exists in various parts of the world? I think that's something that people don't pay enough attention to, because I think it is actually a really important point. And whether you like the regulation or not is beside the point, but I think it exists, and I think it does address an important point in terms of user control over their own data. And so I think it is worth thinking through from the foundation. What does it mean for the right for a user to request their data to be deleted? What does that mean for systems built upon append-only logs, for example? Does it make sense to delete data from an append-only log? How do you deal with that? That really goes to the foundations of how these systems are architected. And so that's another area that I want to think about more carefully.
Yes, as a person from an analytical part of the world, from analytical databases, I definitely can say that it is hardest question all the time.
Mm-hmm.
Okay, so thanks for your answers. Thanks for a great stories and great discussions which we had. I suppose it is time to have a picture.
Photo.
So let us give us some time for people to prepare their book. And
yay!
Yeah.
Wow, this is so nice.
One more time.
So many wild boars in one picture. This is fantastic.
People, smile. Yeah. Cheese. Yeah. Thank you. Thank you very much. I think we need to say thank for Martin for interview and for the great book. It's fantastic book. Thank you, Martin.
Well, thank you all for joining along and all your really interesting questions. I really enjoyed this discussion as well. So it was great to joining you.
Yeah, and I think we all goodbye. Have a nice day. Yeah.
Thank you. And you too.
Yeah.
Have a
Thank
good evening.
you.
goodbye all. Take care.
Goodbye.
Bye.